Hello class, today we're going to go over lesson 2 on elements and the periodic table. Elements can be found on textbook pages 90 to 93. So if something is made up of particles that are all the same, then it is a pure substance. An example of a pure substance would be a glass full of water, because they all are composed of water molecules which contain hydrogen and oxygen. Elements are pure substances that cannot be separated into smaller units. An example of an element would be hydrogen. However, water is not an example of an element because it is composed up of hydrogen and oxygen. Okay, moving on. We're going to discuss the different types of elements, which include metals, nonmetals, and metalloids. Okay, so first we'll start talking about metals. You probably know some of the characteristics of metals, such as the fact that it's shiny, or some of them are shiny. They conduct heat and electricity well, like copper wires. Also, they're blue on the periodic table that you can find in your textbook. They're not always the same color in periodic tables, though. Also, on this periodic table, you can see that they're left of the zigzag line. Another important thing to note is that they have few electrons in their outer energy level. And we'll talk more about why that's important later. Outer energy level. Okay. And some examples of metals are iron, also gold. Iron is Fe, gold is Au. You'll probably start to learn these symbols or abbreviations. And W is tungsten. And Mr. Milsna said that his ring is made out of tungsten. Nonmetals, these are dull. They're non-conductive. Also known as insulators. They're brittle. And they're yellow in the periodic table that's in your textbook. Periodic table. And they're also to the right of the zigzag line. Nonmetals, which we're going to talk about in relation to valence electrons later, they have full or almost full outer energy levels. And there's lots of good examples of nonmetals. One example is carbon, which is C. Most of our body is composed of carbon, or at least a large amount is. And oxygen, which is O. Okay? So now we're going to move on to metalloids. Metalloids have a lot of different properties as well. Some of them are semiconductors, which means that they might conduct electricity well, but not heat as well as a regular conductor would. They're green on the periodic table that you can find in your textbook. And with regards to their valence electrons, their outer energy levels, they have about half full outer energy levels. Examples of metalloids would be something like silicon, which is a good semiconductor. That's Si. And also, with regards to their location on the periodic table, they border the zigzag line. And then these are all differences between metals, nonmetals, and metalloids. But we're going to talk about, or I'm just going to show that on this Venn diagram, that metals and metalloids do have some shared properties. Uh, Nonmetals and metalloids also have some shared properties. And we could talk about semiconductors having some of the same properties as conductors. And then metals and metals really don't have much in common. So we'll just write no. And then in the central portion here where they all combine, we'll say that they have characteristic properties because they're all composed of atoms. Characteristic properties. And I'm just going to pull out of this screen real quick. I just want to show the periodic table of elements. You can see in the red on this periodic table, you can find the metals. And then just to the right of that, you can find in the green the metalloids. And then even farther to the right are the nonmetals. And this right here is a group from top to bottom. And then from left to right, you can see periods, which are all of these. And we'll discuss why that's important in a little bit. Okay, class, now we're going to take a look at the periodic table, and this can be found in textbook pages 336 to 351. So what information is included in each box on our textbook periodic table, or for that, any periodic table? Well, first I want to take a look at this H. And this H is H for hydrogen, and this is known as the chemical symbol. Okay? Next, we'll see a 1, and this 1 relates to the atomic number. The atomic number is the number of protons that an element has. Also, we can see the name hydrogen here, and that is just the chemical name. Then this 1.0, which is a number you'll see on all of these boxes for different elements, is the atomic mass. And the atomic mass is the weighted average of all isotopes of this element, and sometimes we round this. So the background color usually indicates class and category. Obviously this is in black and white, but in some periodic tables, this is what can be an indicator. Also, the chemical symbol color will indicate the state that it is in at room temperature, or the physical state. Now, we're going to move on to the periodic rule of 8, and below we have a table. So the periodic rule of 8 deals with valence electrons and reactivity. Valence electrons are basically the electrons that are found in the very outer energy level. So first we'll go over a general rule. Atoms want a full outer energy level, and the closer that they are to this, they're able to so moving on, valence electrons, once again, are the electrons that are in the outer energy level. So atoms want a full outer energy level, and the closer that they are to having this, the more reactive that they will be. So we can note that this can be either accomplished by gaining or losing valence electrons. And based upon which group an element is in, they'll may either gain or lose electrons more readily. So non-reactive group is the far right group, which is group number 18. And this one is pretty easy because nearly all of the elements in this group have full valence electrons, and they follow the rule of 8, or the octet rule. So right here we'll put 8. Helium has 2, but it has a full outer energy level. So we'll put, this is an atom, there's 2 electrons, and then here's the protons and the neutrons in a helium atom. So all the other groups are reactive because of the fact that they either need to gain or lose electrons. So the closer to a full outer energy level in either direction, the more reactive that it will be. And in this case, we're going to take a look at group 1, which is on the far left. Group 1 has elements like lithium and sodium. They only have 1 valence electron and are very reactive. The reason why they're very reactive is because of the fact that they need to give up only 1 valence electron to be able to form the octet with another atom. And this makes it extremely reactive. Now, moving over to group number 2, which is just to the right of group 1, they have 2 valence electrons. They're still reactive, and an example of this would be beryllium and also magnesium. But the reason why they're less reactive is because now they have to give up 2 valence electrons as opposed, or gain or lose 2 valence electrons as opposed to just 1 in group 1. And in this case, they're going to lose these electrons. Group 13, moving even farther to the right, has 3 valence electrons, and they're even less reactive, as you can see. And the reason why they're less reactive is because they have to lose 3 valence electrons as opposed to 1 on the far left, like sodium. And so this makes it less reactive. And examples are boron and aluminum. Group number 14, they have 4 valence electrons. And a really good example of this is carbon, which is found in period 2. And remember, periods go from left to right on the periodic table. And then just below that is silicon. Now, these are non-reactive for the most part, and the reason why is they either have to gain or lose 4 valence electrons to follow the periodic rule of 8. Now, moving even farther to the right is group 15. They have 5 valence electrons, and they're a little bit more reactive than group 14, which has elements like carbon. And the reason why is because now they only have to gain 3 valence electrons to follow the rule of 8, form an octet, and become more stable. In period 2, nitrogen is a good example, and then just below that in period 3 is phosphorus. And once again, periods go from left to right, and groups are vertical columns. So in group 16, they have 6 valence electrons. They're a little bit more reactive, and the reason why we're getting more reactive again is because now they only need to gain 2 valence electrons, or two electrons. And a good example of this is oxygen, which bonds with hydrogen readily to form water, and just below that in period 3 is sulfur. Now, to the most reactive group on the right, group 17, has 7 valence electrons, which means they only need to gain 1 valence electron in order to form an octet or follow the periodic rule of 8. This makes them extremely reactive. A good example of this is fluorine. Period 3, which is just below fluorine, an element that's a good example is chlorine. And then to our far right, group 18, also known as the noble gases, has 8 valence electrons, and obviously 8 follows the rule of 8, or the octet rule. They don't need any more valence electrons. The reactivity is very little, if any, and examples of this in period 2, and then going down to period 3 are neon and argon. And just to give a slight example here, if you have sodium on the far left, which is very reactive and only needs to give up one electron, and you combine it with chlorine, you can form table salt. And usually, sodium by itself, or won't be found by itself as just an ion, and is usually found in different molecules, and actually by itself is very reactive in water. And chlorine gas is a very poisonous gas, but if you put these two elements together, you'll form NaCl, which is table salt, and something that we eat every day. And that's the end of this lesson.